So we've got another revision clock here. Again, this time I'm going to look at the stages that you need to make sure you have full understanding of for the physical fieldwork. Remember, each section, spend 5 minutes revising on, go away, test yourself on them, and so on until you're familiar with this entire sheet. So the physical fieldwork, we looked at have humans affected the movement of sediment along Worthing's coast. Remember, you need to know that title. As I said in the human video, if you don't get the title quite right, so you say have humans affected longshore drift along Worthing's coast, or to what extent have humans been able to stop the movement of sediment along Worthing's coast, that's fine. It's got to be something that is geographically relevant and correct. So the first section is going to look at the justification of our study. So why are we doing this? Okay. Now, this links into the curriculum in terms of coastal defence. Okay, Worthing is a large coastal town with a population of over 100,000 people, and it therefore is valuable land. If we think about cost-benefits analysis, the cost of not protecting Worthing versus the benefits of doing so is greatly outweighed. So as a result, there is significant coastal protection going along the Worthing coast. For example, we do have examples of rock armour and gabions outside Splash Point Leisure Centre, but probably most prominently and visible are the groins along Worthing Beach. At Worthing, we have sediment moving from the west to the east, so moving across in the direction of Shoreham. Okay, and what has been built is large groins in front of Worthing, perpendicular across the beach, to stop that movement of sediment by longshore drift. Okay, and we're going to look at, are those groins effective? Are they actually doing the job that they were intended to do by stopping sediment, therefore building up a beach and providing Worthing with that necessary protection? So we then move on to the justification of the study. Okay, now this is actually very similar to what we had earlier. Darlington High School is only 3 kilometres away from Worthing seafront, so we have very small travel time and very small travel costs. Fundamentally important when you consider the number of students we were taking. Also, the beach is accessible. It's a public beach, therefore we had easy access to it with a large promenade at the top, so it was a great place to congregate safely as a large group. On top of that, Worthing Beach has a relatively large tidal range. This meant that at low tide, risk of drowning and so on would be very low. This then moves us in nicely into our risk assessment. Okay. Obviously, the highest risk that was posed to us, and in the case of most physical field work, okay, if you're doing rivers or coastal work, is obviously the risk of drowning. Okay. As a result, we waited until the afternoon to do our study, because that was when low tide was. We researched when low tide was before we went away. We found out that low tide would be after 2 o'clock, about 2:15, and that was when we went down to the beach. This meant that even when working on the groins, would be a long way away from the water. To help with this, also we obviously instructed nobody to go in that, and we kept a minimum of 5 metres distance from the sea. One of the other major concerns was the height difference between sides of the groins. If the groins had been effective, as we hoped to find they would be, sediment would have been trapped on one side, meaning that it would be much higher on one end or on one side than the other. So what we asked was that obviously you didn't jump from one side, you walked and crossed the groins where the beach height was relatively similar, and you wore appropriate footwear for working on the beach, so not open-toed sandals or loose shoes, things like walking boots or trainers. And like with the human work, obviously we had to contend with the risk that the weather posed, that there was the potential for cold or wet weather. We again were very fortunate, very nice, warm, dry conditions, but we made sure that everybody had the appropriate warm weather, cold weather clothing to keep them warm. So, moving on to the data collection then, a little bit shorter than the human one here. We only had 2 bits of data we collected. The major thing that we were looking at collecting was the beach height. So in groups, we chose 1 groin each to study. We did a systematic sampling. Now, systematic sampling means that we only sampled at certain points along a transect. So our transect was the length of our groin. And what we did was every 10 metres, we sampled the beach height on the west side of the groin and on the east side of the groin. Okay. We started from the top of the beach, at the top of the groin, and worked our way all the way down to the end in those 10-metre intervals. Now remember, it's more important you're going to be asked, why did you do that? To justify your data collection. So we need to justify the theory behind it and then the methodology. So the theory behind this was that beach height either side of the groin would indicate if sediment is being trapped. We expected, if the groins were successful, that the west side of the groins would be higher than the east side. That's because, as remember, longshore drift is moving from the west to the east, so sediment should be being trapped up against the west side of the groin. If the beach height showed that the beach was higher on the west side of the groin, that would indicate that the groins were being effective in their stopping of sediment moving along the coast. In terms of the sampling, we did systematic sampling. There are problems to that, which we'll come on to, because obviously if you're only measuring 10 metres, you're missing out a lot of data points in between those 10-metre points. But we had to remember that we only had limited manpower and limited time. We needed to get the sampling done and the measurements done before the tide came back in and imposed a greater drowning risk. We also collected pebble size. So at those 10-metre points down the groin, at the same points that we were doing our systematic sampling of the beach height, what we did was we collected 10 pebbles at random from the east and the west side of the groin. We used what we call a heel-to-toe method. So if you remember, what we did was we put one foot out in front and we picked the stone up at the end of our toe. Once we picked that stone up, somebody measured that, and then we put our foot in front of the next one, okay, and picked up the stone there, and so on. We then measured the longest axis that we could find on these pebbles. The theory behind this, the justification behind this, is that the larger pebbles should collect on the updrift, i.e. the west side of the groin, okay, if the groins are being effective in stopping longshore drift, and it's only the smaller, lighter pebbles and sediment that should manage to get round to the east side of the groin. The random sampling was done, that heel-to-toe method, because of the population size. We were only going to be collecting a very, very small population in a massive beach of pebbles. I mean, there's simply no way we could collect and measure all the pebbles. We simply would never have the time or the manpower. So we had to collect a sample of this, and random was the best way to do this to try and avoid any bias. Okay. So let's have a look at the data presentation then. Now for the beach height, what we did was we used a line graph that showed both the west and east height of the beach in comparison to the top of the groin, okay, and also showed a mean height. So you ended up with something that looked a bit like this, with the west side of the groin, remember that was the higher one, so the line being like this, and the east side slightly lower down, okay, showing distance down the beach and height from the top of the groin downwards. Now, the major positives of this, remember, they're not going to ask you what you did, they're going to ask you to justify it or assess its effectiveness. This was a highly effective presentation strategy. Firstly, it allowed us to compare the height of the groins, the height of the beach on either side of the groins on one graph, so you could clearly see if one was higher than the other. It also allowed us to compare the mean height, okay, so it kind of added a layer of complexity to the graph and meant that any anomalous points could kind of be easily identified. On top of this, we then located our graphs onto a base map or an aerial photo, so we could show what groin on Worthing Beach we actually measured. Okay. On top of that as well, the positive of using a line graph, it allows us what we call interpolation of our data. So remember, we used that systematic sampling where we only measured at 10-metre points down the groin due to the time constraints of the tide coming back in. But what we could do is by joining up these lines, assuming that the beach takes a sort of steady change between the heights at each point, we could actually now start working out, for example, what the height of the beach may have been. We could approximate what the height of the beach would be at like a 15-metre interval rather than just our 10-metre sections. The only negative about that is that it does assume a constant steady change between the data points. So we're assuming, for example, between metre 20 and metre 30, that the beach does sort of changes in that height in a straight line at a steady gradient. It's more than possible that it could have gone up in beach height at that point and then dropped very sharply, or dropped very sharply and then gone back up, rather than taking that steady change. Other ways that we could have done it, we could have used alternatives could have been, for example, a proportional diagram, okay, showing beach height, or just a bar graph, bar graph, 10 metres down, beach height at either end. Okay, but that wouldn't have allowed for that interpolation between the points. So what about the pebble size? Well, what we used here was a box plot graph. So something like this, you would have had the two sort of graphs alongside each other, showing the mean pebble size collected at each 10-metre interval down the beach. Now, massive positives of this, again, like most of our graphs, if you're ever struggling in the exam to remember an advantage, we located this onto a base map or aerial photo. So it allowed us to see the spatial pattern of the data and would allow somebody else to then find the exact same groin that we did and repeat the experiment if they wish to. The good thing about a box plot is it shows the range of sizes found. So, for example, on the west and the east side, you'll have the difference between the smallest and largest pebbles found, or in this case, the smallest mean and the largest mean. The major advantage of using box plots is that it measures and shows measures of central tendency. So, for example, you have interquartile ranges, upper quartile, lower quartile ranges, and the mean. And
again, going back to this, it's nice to have that side-by-side comparison. You can make much easier sort of statements of comparison between the two when the box plots are next to each other. The major negative of this was that we had a pretty small sample size to draw from. We only used the mean points of each pebble measurement down the groin. Now, considering that the groins were generally between 50 and 70 metres long, that may mean that you were drawing a box plot from 5 or 7 pieces of data, which generally isn't really enough. So alternatives, again, we could have used a bar graph, showing mean pebble sizes. We could have used a proportional diagram, with a pebble, and depending on the size of the pebble, relating to the mean size found at that point. There were alternatives there, but I said the box plot particularly good because it shows those measures of central tendency and it allows us to see the range of sizes found and make that side-by-side comparison. So we're then going to move on to looking at whether or not the results were useful in making conclusions relating to the original purpose of the investigation. That's what we might get asked, is to what extent were the results you gathered useful in drawing conclusions relating to that original answer or original question of our investigation. And the simple answer to that for our physical geography is yes. Both pieces of data show that the groins along Worthing Beach were effective. If we were to have a little look at the data that one of the groups collected, mean beach height on the west side of the groin was only 10.5 centimetres down from the top of the groin. On the east side it was 90.5, so it's talking about an 80 centimetre difference in beach height between the west side of the groin and the east side. The pebble size showed a very similar kind of trend. We had a mean pebble size for the whole way down the groin of 75 millimetres in terms of its longest axis on the west, and only 20 millimetres on the east. And that fits in with the theory that we talked about when we thought about our methodologies and our results that we were collecting. We were expecting that if the groins were being effective, that they were stopping material being moved along Worthing Beach, that we'd see a higher beach height on the west and a larger pebble size. And that is what we've seen. So that suggests that the human-built groins are trapping sediment, and therefore humans are having an effect on the movement of sediment along Worthing's coast. But what we've got to remember, and we talked about this in the human one, that really any conclusions are only as strong as results, and therefore the method that they're based on. If our methods have issues in them, there's weaknesses, there's limitations, there's problems, we have to accept that our results have similar limitations, and therefore the strength of our conclusions is weakened. As I said here, the strength, validity of conclusions is weakened, but not completely invalid. This is the point I want you to take away from here. If we're having a look now at our problems or our limitations of our data collection, it's quite straightforward to see some of the issues. If we start off with the beach height then, and we're going to break down our problems or limitations into reliability problems and accuracy problems. Now remember, reliability problems is kind of how well that data represents the whole population. And accuracy is actually, did we measure it correctly? Were there mistakes in the way we measured it? So for example, the reliability for the beach height. Each group only measured the beach height either side of one groin. That means that the population size is very, very small. It's possible that that particular groin that group chose was effective at stopping longshore drift. It may have been, for example, Worthing's Beach, the groins are kind of updated, they're modernised, they're repaired on a cycle. So we may have chosen a groin that had only recently undergone repair, and it may have been that if you'd gone further on the beach where groins were starting to deteriorate and start to break, that we wouldn't have seen such clear data suggesting that they were working. On top of that, we only did a 10-metre systematic sampling. Now that has some major issues in it, There's a high potential for important data to be missed, in between our points. It may be that we measure at 0, 10 and 20 metres, but maybe at 15 metres, the beach height was actually higher on the east than it was on the west. So the reliability of our data is quite low. There's a high chance of bias. In terms of the accuracy, there were a few things. We had to assume the top of the groin was consistent. And in most cases, this erosion and wear and tear had meant that the top of the groin had kind of warped slightly. So there's a chance that we weren't measuring from a steady position. There were also high winds on the beach of the day, which was causing the tape to bend, or even the meter rules that were quite a flimsy plastic to bend as well. So again, there was a high chance of mismeasuring the data and measuring the height incorrectly. Now, in terms of the pebble size, Okay, reliability here is the major issue. Okay, it was an incredibly small population of sample size. Okay, so it may not represent the whole population of pebbles on the beach, and there's millions of pebbles, simply no way we could measure all of those, and we're making judgments about how effective the groins are based on measurements of maybe 70 pebbles. Yeah, there was also a high chance of bias in choosing the stones. Remember, we used that heel to toe method where we put our foot out, we chose a pebble in front of it, then put the next one in front and chose the pebble from that. But there was still a human choice then which pebble you picked up at the end of your toe. And we also had a bit of vertical bias. You're also only picking up pebbles from the surface layer. It's very likely that smaller pebbles would have infiltrated their way through the gaps down to the lower levels of the beach. In terms of the accuracy, it was sometimes quite difficult, particularly when pebbles were well rounded, to determine the longest axis of the pebbles, so which one to measure. And obviously, when you're trying to measure something round with a straight ruler, there is a high chance of making a mistake. So we talked about this idea of the impact on conclusions. Yes, our conclusions are relatively strong, okay, but we have to accept that there are weaknesses in the way we collected the data. Therefore, there are weaknesses or kind of questions over the validity of our results, and therefore our conclusions aren't as strong as they could be. And it's about in the exam showing an understanding of that our conclusions are not foolproof, they're not bulletproof, strong. Right, going then on to the evaluation. Okay, so this is how could we improve our data collection. Now, one of the most obvious things to do if we talk about improving the beach height measurements would be to measure along more groins. So rather than just doing one, measure maybe 5 or 10. What we could have done in this case actually is collected everybody's group's data. You know, as a school, we probably measured around 30 groins. Okay, so you could have made sort of comparisons over all of those 30, increasing the population, the sample size, so it's more likely to represent the whole groins or whole population of the groins along the beach. One of the other things as well was to increase the frequency of the systematic sampling. So for example, only measuring every 5 metres or every 2 metres. This means the data is going to be more reliable and there's going to be less chance of any anomalies such as a particularly effective groin impact on our conclusions. One of the other things that we could have done as well is Worthing Beach Office actually would be able to provide secondary data. They actually do, obviously their job in terms of protecting Worthing Beach is to measure the effectiveness of their groins. So they have historical records dated back 20, 30 years of beach height measurements either side of the groins. That would have allowed us to see if the groins were being effective over a longer period of time, and again would have meant that we had a larger sample size data to make our conclusions from, which means our conclusions are going to be more reliable. In terms of the pebble counts, the simple thing to do here would be again to increase the sample size by counting more pebbles. Okay, this would mean that there was a higher reliability of our data, that there'd be a high chance of the sample representing the whole population. You know, the chances are here that there's a limit to how far we could go. As I said, there's no way we could measure all of the pebbles, so it's just about measuring, you know, as many as we can in the time to increase the sample size. The bigger the sample size, the more likely it is to represent the whole population, therefore the more reliable the data. In terms of improving the accuracy, what we could have got was digital calipers. You know, these digital calipers basically use like a kind of a system where you put the pebble in and then you'd kind of twist it so that the calipers, the sort of arms of the caliper would go until they were touching the either side and able to grip either side of the pebble, and then it would give you a digital reading in millimeters of how long the axis is. So your data can be likely to be much more accurate than trying to measure it with a ruler.